Okay, here's problem 7, and it's a little bit more complex than the previous problems. It says find the area under the curve formed by the equation y equals 2x over the quantity x plus 1 squared and bounded by the x-axis and x equals 2. And what I did is on my calculator, I graphed that, and that's what that looks like. So I'm talking about this area over here in which I'm trying to figure this out. Now, notice it's bounded by this curve right here. Here's the line x equals 2, and here's the x-axis. And so this point right here is x equals 0. And I can figure that out because on the x-axis, y is equal to 0. So I am solving the equation 0 equals 2x over x plus 1 squared, and the only way you can make y 0 is if this numerator is 0. So then I write 0 is equal to 2x, and if I solve, 0 is equal to x. So I'm integrating then from 0, my left-hand corner, to 2, which is my right-hand corner, this particular integral. So I have a definite integral in this case, and I'm integrating this. And to begin with, it does not look like it's a natural log, because I have in parentheses a quantity and I have 2 here, which is not 1. So I'm thinking, well, I'm going to reverse the power rule, and if I take a look at this and I let this derivative equal to 0, I'll get 1, and that's not the derivative I have up there. And I can introduce constants, I cannot introduce variables, so I'm stuck. So I'm going to take this a step further, and I'm going to rewrite this, and I'm going to expand or FOIL the denominator, so I get x squared plus 2x plus 1, and I'm going to put parentheses around this quantity, and I have the first part, again here's my dx. And so I'm thinking natural log, and if I take the derivative of this, I get 2x plus 2. Well, I have the 2x, but I don't have the plus 2. So I'm going to do kind of a common math trick, is I'm going to add 2, but if I add 2, I have to subtract 2. So really, I'm just simply adding nothing. I'm just rewriting what 0 is here. And then I'm going to go about, and I'm going to break this down into 2 integrals. Well, I'm going to break this down so it looks like this, and then I'll break it down to 2 integrals. I'm integrating from 0 to 2 of 2x plus 2 over x squared plus 2x plus 1. And the reason I want to do that is because the derivative of what's in this quantity is in the numerator. So that's going to fit my natural log. Okay, let me just get rid of what I just wrote. Minus, there's my minus up here, 2 over, and rather than write the x squared plus 2x plus 1, I'm going to go back and write it as x plus 1, the quantity squared dx. Now, the derivative of x plus 1 is 1, and I know there's a 2 up here, but I can write that as 2 plus 1, and I can bring out the 2 in front of the integral, and I'll have that derivative up in the numerator. And so I'm going to break this into 2 separate integrals. I better write it over here. One of them is going to be this, 2x plus 2 over x squared plus 2x plus 1 dx minus, now I'm going to bring that 2 out in front, and we're going to integrate from 0 to 2 of 1 over x plus 1 squared dx. And I'm going to approach each of these integrals separately. I'm going to use natural log here. I'm going to reverse the power rule here. Why am I doing that? Because the exponent is 1 in this case, and the exponent is 2 in this case. So I have 2 different methods. So over here I'm going to let u equals x squared plus 2x plus 1. That means du dx is going to equal 2x plus 2. And so du is going to equal 2x plus 2. that quantity times dx, and that's what I have. So that means now it's going to look like, I'm going to get rid of these numbers to begin with, and I'm going to have 1 over u du. And so the 2x plus 2 times dx is du. The x squared plus 2x plus 1 is u, and when I integrate this, I get the natural log of the absolute value of u, which means I have the natural log of x squared plus 2x plus 1, absolute value. And since it's a definite integral, I have to integrate from 0 to 2, which gives me the natural log of, well, 2 squared is 4. 2 times 2 is 4, plus 1 is 9. So it's 2 squared plus 2 times 2 plus 1, that, minus, here's that, remember that's my b, minus a, and I'm going to have 0 squared plus 2 times 0 plus 1. And so I have the natural log of 9 minus the natural log of 1, and the natural log of 1 is 0, so I have the natural log of 9 minus 0, which is equal to the natural log of 9. Alright, so that takes care of this part right here. Now I'm going to take this part, so I have a minus 2. And what I'm going to do here is I'm going to let u equal x plus 1. So that means du dx is equal to 1. That means du is equal to dx. So I'm going to write this as a negative 2. I'm going to drop the a and the b for a second. And I'm going to have 1 over u squared du. That's a negative 2 integrating u to the negative 2 du. And that means I have a negative 2 times a negative 1 u to the negative 1, which gives me 2 over u, which means I'm evaluating 2 over x plus 1 from 0 to 2. And if I do that, I'll have 2 over 2 plus 1 minus 2 over 0 plus 1, which is 2/3 minus 2, which is a negative 4/3. So now I have the natural log of 9 minus 4/3, and that's my answer. That's my area underneath the curve. Alright. And we can check that out. Let's bring this back up. Let's see if I can integrate this. Let's see if I can remember that. Shift G solve. I want to integrate from 0, execute, to 2, execute. There, it figures it out. And I get 0.8638 or 0.864. So let's go back to menu. Let's come up here, execute. Let me clear some of this stuff. And I got the natural log of 9 minus 4 divided by 3. And I get exactly the same answer. So it's a good way to check to see that I did everything correctly. So I'm going to close this screen. And I'm going to clear this. And I'm going to take a look at example 8. And example 8 is I'm integrating x squared plus x plus 1. And that's a trinomial with a degree of 2. And down below I have a binomial with a degree of 2. And so when you see this, you're going to see this in your book. I think it has a 2x squared something. You're going to want to do long division. So my divisor is x squared plus 1. And I'm going to divide it into x squared plus x plus 1. And how many times does x squared go into x squared? It's one time, and I got x squared plus 1, and what I do is I change into the opposite signs and add, and I'm left with x. So I can rewrite this rational expression as 1, my whole number, plus my remainder over my divisor. And what I'm going to do is break this up into two separate integrals. So I'm integrating 1 dx plus the integration of x over x squared plus 1. And notice I'm going to put a quantity around here, 1, so I'm thinking natural log. Derivative of x squared plus 1 is 2x, and I got an x up here. So that is looking good. The antiderivative of 1 is x plus whatever this is going to be. So I'm going to let u equal x squared plus 1 du dx is equal to 2x. du is equal to 2x dx. So that means 1/2 du is equal to x dx. So now I'm going to substitute, and I'm going to have 1/2 1 over u du. That means I'm going to have 1/2 natural log of the absolute value of u plus c. So now I'm bringing in my x's. There's this x right here. Don't forget about that. Plus the natural log of the square root. That's my 1/2 power of x squared plus 1 plus c. And that's the answer for that. Number 9. Number 9 is going to ask for the average value, and the average value is computed this way. It's equal to integrating a to b of f of x dx divided by b minus a. So in this case, I'm going to be integrating the tangent of x dx from 0 to pi over 4 divided by pi over 4 minus 0. Well, on the bottom, that's going to give me pi over 4. And from a previous problem, we know the derivative of this. I believe it was the negative natural log of the absolute value of the cosine of x, and that's evaluated from 0 to pi over 4. So that means I'm going to have a negative natural log of the cosine of pi over 4 minus, remember, the antiderivative with b in it minus the antiderivative with a in it, negative natural log of the cosine of 0 all over pi over 4. Well, this is the negative natural log of the cosine of pi over 4 is the square root of 2 over 2. Subtracting a negative is like adding the opposite, so it's plus the natural log of 1 over pi over 4. So the natural log of 1 is 0, so I have, and this is like multiplying by the reciprocal, so I have 4 over pi times the negative natural log of the square root of 2 over 2. So I have a negative 4 over pi times the natural log of the square root of 2 over 2. Now I could simplify that even further, but I think I'll just stop right here. Alright, the last problem is on the back of the notes. You can probably hear me changing it. And it's example 10. And it looks like this. 3x squared plus 1 raised to the second power times 6x dx. Now there are two ways I'm going to go about this. One's a little bit more straightforward than the other. First of all, it's not a rational expression at all, so I will not be using the natural log. One way I could do it is I could FOIL this and multiply through by the square root by 6x. So if I FOIL this, I'll get 9x to the fourth plus 6x squared plus 1 times 6x dx. And then I can multiply through, and I would get 6 times 9 is 54, x to the fifth plus 36 x cubed plus 6x dx. And now I can do the antiderivative on each of these. I'll have x to the sixth, and I'm going to take 54 times its reciprocal, so 54 times 1/6 is 9, plus x to the fourth, and I'm going to take 36 and divide it by 4, and I'm going to get 9, plus x squared. I'm going to take 6 and divide it by 2 and get 3 plus c. And if that makes sense to you and that works, more power to you. Another way I can do it is I can see that in this quantity right here, this 3x squared plus 1, the derivative is 6x. So I can make u this. In other words, I can say u is equal to 3x squared plus 1, so du dx is equal to 6x. That means du is equal to 6x dx. And so what I have here is I have u to the third du, and that's going to be 1/4 u to the fourth plus c, or 1/4 parentheses 3x squared plus 1 to the fourth plus c. And if I did that, I would get exactly the same answer. Alrighty. Oh, you know what? I'm going to pause here. I almost started. I see what I made my mistake here. And you guys are wondering what I'm doing. This should be a squared, right? Because there's a 2 here. And this should be a 3. And this should be a 3 here. And there should be a 3 here. And this should be a 3 here. So this is the same as 1/3, sorry about that, 3x squared plus 1 cubed plus c. And if I would cube that, I would get this.